Okay, this is Mr. Peterson, and I'm going to show you how to solve systems of equations algebraically, which means we're not going to use graph paper like we did in the last lesson. And I do want to give you a quick rundown of the advantage of this new way of doing it, substitution method. We will actually learn another method on the back page of this note set, but you can see that when we looked for a place where lines crossed on the last lesson using graph paper, sometimes they didn't cross right on a grid mark and you really couldn't tell where they crossed. So you might think this crosses at 1.2 to the right and or maybe 2.2 to the right, and your friend thinks it crosses at 2.3 to the right. Not easy to tell which one of you is correct, and you might both be wrong. So the graphing method we learned last time doesn't always give a location that's easy to tell where they intersect. So we're going to learn two methods, the substitution method being the first one, where we're going to get an accurate answer. Okay, so let's start here with the substitution method. Over the years, I've learned to write the two equations side by side. So think side by side substitution. Okay, once you've got them side by side, you want to look for a place where the lines cross. You want to look for a place where you've got either a 1x or a 1y. So I'm going to use this one right here, although I could have highlighted the one over there. You're going to start by solving for that variable. So in this case, I'm going to take and add 2x to both sides. Simply take that over and change the sign. And you stop working on this side at this point, so I'm going to draw a line there. And we now have an expression that's equal to y. This 2x plus 8 is the same as y, it says right here. That's what the equal sign's about. So we can substitute in place of y. Come over here and put a pocket. You want to use parentheses when you do this. And instead of that y, we'll substitute or replace that y with a 2x plus 8. And by doing so, we now have only one variable to deal with. We have these x's, and we don't have any y's anymore. So what's going to happen here is we're going to be able to solve for x. So combine these like terms, 2x and 3x is 5x, and we have an 8 here. We'll take care of that in a minute. Subtract 8 off both sides. And if you take 8 away from negative 2, you get negative 10. And then we'll divide both sides by 5. You're used to seeing it written underneath here as divide by 5, divide by 5. But I'll just say divide both sides by 5. And you've got your first answer. X has to be the number negative 2. Well, since you know x and 2 are the same thing, they can substitute for each other. So we're going to come over here and say that x can be, we can put negative 2 in its place since we now know its value. And we do the number crunching over here. And that tells us the y value has to be 4. So what we have here is an x value of negative 2 and a y value of 4. And the proper order is x and then y. Even though we're not using a graph, this is still a point. So you can go negative 2, 4. What this is the x and y values that make both the top line true and the bottom line true. Okay, example 2, 2x plus 3y equals 7. You can see I wrote that side by side with the other one. And on this method, you always want to find a place where there's a 1x or a 1y. In this case, right there. Now, the reason we do that is if we're solving for this, and it's got a coefficient of either 1 or negative 1, then when you divide by that 1 or by that negative 1, you don't end up with fractions in the problem. Compare that with trying to get this y by itself. Eventually, we'd have to divide by 3, and we'd have 7/3, 7 over 3, and we'd also have 2/3. To avoid those fractions, we're going to do it. So look for a place where it's got a 1x or a 1y. Sometimes you can't avoid the fractions, but on these problems you will be able to. Alright, so you get 1x here equals 2y minus 7. And now we're going to substitute on the other side. That x is the same as 2y minus 7. So we're going to replace the x with 2y minus 7. Distributing here gives 4y minus 14. Combine my like terms and take this over to the other side. I get 7y over here, and I'm going to add 14 to both sides. And then divide by 7, and you get y equals 3. So now you substitute again. There's always two substitutions in these problems. We're going to replace the y with 3. Negative 6 take away 7 is negative 1 for my x value. And you put it in order, x first, then y. And you have your solution. So if we were to graph this, these lines would have crossed 1 to the left and 3 up. There's our other solution. Okay, we're going to get a different situation that we have to learn how to deal with on problem 3 here. So what we have here is a 1x right here, and we have a 2y, a negative 2x, and a 4y. You always want to start, if you can help it, with the coefficient that's 1. So you can see there's a 1 in front there. And the reason for that is if I solve for this x, eventually dividing everything by 1, you're not going to get fractions here. So all we're going to do here is take that over to the other side. And that expression, negative 2y minus 6, will substitute for the x, since they're equal. Okay, if you distribute here, you get 4y plus 12, and then the rest of it is minus 4y and equals 8. And this leads us to a little bit of a strange situation. These cancel off because they add up to 0 on the left side, so you get 12 equals 8. That expression is never true. That statement is just a false statement. And when you get something like this, it's never true. It's an indication that your graph would have been parallel lines. And we learned last time there is no solution to this. And if you're learning the extra word that goes along with it, this is described by mathematicians as an inconsistent system. You will be required to put parallel no solution. This here we've decided is going to be, we're just trying to teach it to you, but if you leave it off, you won't be marked wrong. Okay, now, if I followed the same path that I did last time, I would highlight this y because it has a 1 in front of it. And that is actually the best choice. But I want to do this one a little differently, just because you will have some where there's no x, 1x, and there's no 1y, or negative 1x or negative 1y, like this problem actually has. So I want to come over here and discuss with you how we could do it differently, okay? If I solve for this x, it would be a poor choice. And the reason for that is I'd eventually have to divide everything by 9 to get the x by itself. And you can see that if you divide that by 9, you'll get a fraction, negative 1/3 to be exact. And even here, if you divide this by 9, you get positive 1/3, and we'd have those fractions to deal with. So instead, I'm going to get this y by itself, and I could divide by negative 3. That would make this into an integer number, negative 3x. And if you divide this by negative 3, you also avoid the fractions. So I'm going to get this part by itself, even though the better choice would be to come over here and get that by itself. Okay, so here goes. Negative 3y equals, when that goes over to the other side, it's negative 9x plus 3. And I'll divide everything by negative 3. And it's more work than it would have been getting this y by itself. But we still have avoided fractions. Now that will replace the y value. So I'm going to replace this y value with that expression. There's a 1 there, and we distribute, so it's turns out to be plus 3x here minus 1, just multiplied by 1 across there. And these cancel off, they give 0, so you get negative 1 equals negative 1. Now, unlike the previous where we had something impossible, 12 equals 8, that was never true, here we get something that's always true. Negative 1 always equals negative 1. And that is the behind-the-scenes indication of coinciding lines. If you remember last time, sometimes we got the same line twice. And that's also an indication of infinitely many solutions. And that's a dependent system. I'm running out of room to write here, but I'll just put an arrow down here. Dependent. Okay, so now we're down to a word problem, and you want to do these problems, okay? Don't just skip them. You have to grapple with them. They teach you a lot, okay? So you read the whole problem, and then you want to usually go to the end to find out how to start the problem. So here we go. At Rinaldi's Pizza, 1 soda or a soda and 2 slices of pizza of the day costs $10.25. If you buy instead a soda and 4 slices of pizza, it's $18.75. So you're supposed to find the cost of each item. So we're looking for the cost of a soda. And I'm going to the end to find that out. I'm looking for the cost of each item. Cost of a soda, I'll call that X. And the cost of pizza slice, I'll call that Y. Now, the first time around, we buy 1 soda and 2 slices of pizza. And one times the cost of a soda and 2 times the cost of a pizza is a total cost of $10.25. Now we're solving this by subtraction. The other one side by side with this. So if you buy a soda, so 1 times the cost of a soda, plus 4 slices of pizza at $Y each, so 4 times the cost of a pizza, you'll spend a total of $18.75. And then once you have it set up, you do the same technique we did above to solve it. So I'm going to start with either this 1x or that 1x. You can also use negative 1x in a pinch, but I'm going to get that one by itself. So take this over to the other side and I have an expression that equals x. Now, since these are equal to each other, they can trade places with each other. So I'm going to take that x and call it negative 2y plus 1025 instead. Now the rest of it is plus 4y equals 1875. Distribute the 1 all the way across, at least as far as here and here. And I'm going to take this over the other side and subtract it, but I'm also going to combine these like terms. 1875 minus 1025. So 2y is equal to $8.50. And divide both sides by 2 and you get 425 is the cost of, I believe, the pizza. Yeah, the cost of a pizza is $4.25. Now I'm going to take that information and substitute back on the other side for the y, because those are equal. That's equal to y. And that puts me at an x value of, let's see, this multiplies to give negative 850 plus 10.25. And if you subtract 8.50 from 10.25, you get $1.75. Okay, so the cost of a soda is $1.75. Here's your answers. And the cost of a piece of pizza is $4.25. Okay, and that does it for page 1, and we'll pick up on the other side with another method called the elimination method on page 2.